evening to all of you who have joined us today. Um, Today, we have with us Agam, who's an expert in provisioning Microsoft Azure solutions, M35, and Cloudflare. He specializes in cost optimization, performance, and security services. He has worked on SAP on Azure, Azure Virtual Desktop, Kubernetes, and DevOps projects. And today, he would be mentoring you about the DevOps. Over to you, Agam. Thank you.
All right. Thank you so much, Anamika, for that introduction. Hello, everybody from the Azure Dev community. Myself, Agam. So, as Anamika has already shared my intro, I'll just bring up the profile. All right, so let's get started. So, today our session is to discuss in brief about the Azure DevOps. So, let's look at the topics what we have today. So we'll start with discussion on history and prerequisites of DevOps first. Like what are the prerequisites? And because lot of the people amongst you would be in college, right? So of course I would like to let you know, guys, that what all goes in the background and what are the prerequisites before you jump into the main topic. We'll explore that why DevOps is important, what is the goal of DevOps culture, what are the steps to embrace DevOps, and why DevOps is bringing in financial benefits, saving opportunities, and all other stuff. So now let's jump on the topic of history and prerequisites of the DevOps. All right. So before we discuss the main topic, I would like to address the community here about the um, background. So basically, what developers do and how DevOps came into existence. So basically, uh, in the previous days, what used to happen, like in the till the mid 2000s, nobody knew about the DevOps term, and there were the developer team and the operations team in the industry used to work differently. Okay, so there are a lot of important things with respect to developer and with respect to the IT administrator, which we should know about before we can jump onto the main topic. So why DevOps? So DevOps is the amalgamation of the development and the operations teams in an organization of approach that enables faster development of the applications and easier maintenance of existing deployments. So, by enabling the organizations to create stronger bonds between the DevOps and other stakeholders in the company, so DevOps, what it does is it promotes shorter, more controllable iterations through the adoption of best practices, automation, and new tools. And DevOps is not a technology per se, but it covers everything for the organization to culture, processes, and tooling, etc. So initial steps include the CI/CD, which you have might have heard about. Also, some real-time monitoring, incident response, and collab platform. So, uh, what developer prerequisites is required? आपको ये पता होना चाहिए कि what is software developer life cycle model. कि अगर आपको ये पता होना चाहिए basically that so mine I would like to also address here that my session would be a mix of Hindi, which is the most understandable vernacular here, uh, as we are delivering this session for Indian audience as well. So Hindi as well as English. So please bear with me. So in developer life cycle, what happens is that we should know कि software development life cycle क्या होता है, how a software is developed from stage 1 to stage n. Next, we should know about the Linux basics. Why? Because Git is a tool, version control system, जिसके अंदर लिनक्स के बेसिक्स यूज होते हैं, सो वी शुड नो अबाउट दैट. नेक्स्ट इज कि जो प्रोसेस होता है बिल्डिंग of code and then testing the software and then the quality assurance part, that also should be covered up before we get into the main topic. Next is version control. So version control is just another, it's a source control management system, which is and it has different version, its own types also. So ये भी एक जरूरी चीज है जो हमें पता होनी चाहिए. Next is the IT operations part. अब if anybody is from the community who is already working in the industry, or they are students, or they are IT veterans, they already know कि when we work in the industry, so there are a lot of IT operations or IT profiles apart from the developers. So that include the specific to IT domain. There are other things like network administrator, system administrator. There's a Windows slash Linux administrator. So all these profiles are also important for the overall डिप्लॉयमेंट ऑफ द कोड. सो जो आप डेवलपर्स ने कोड क्रिएट कर दिया है, दे हैव ऑलरेडी पैकेज द सॉफ्टवेयर, बट वेयर टू डिप्लॉय इट. So all these and after that we have to maintain that infrastructure also. So all these processes is done by the IT administrator slash uh, the Windows or Linux, wherever the application is hosted. And this is all these processes in the last four parts, which is deployment, maintenance, monitoring, security, and sustainability. This is taken care of in by the IT administrator. So we should know basics about that, which we'll explore in the later slides. So basically, what SDLC models are and challenges are with IT operations. Let's discuss that first. I hope the screen is visible to everybody. राइट. सो लेट्स डिस्कस कि एसडीएलसी मॉडल्स के अंदर क्या होता है और क्या चैलेंजेस होते हैं विद रिस्पेक्ट टू आईटी ऑपरेशंस. सो अर्लियर व्हाट यूज्ड टू बी देयर इज कि लेगेसी मॉडल्स होते थे एसडीएलसी के अंदर, विच इज वाटरफॉल मॉडल एंड मेनी अदर्स. सो उसके अंदर प्रॉब्लम्स क्या थी कि there it was not feasible. So for example, if we wanted to create a projects, create a software, then we need if we used waterfall model or any other legacy model, तो उसको चेंज करना, और अगर क्लाइंट को चेंजेस चाहिए, इट वाज अ वेरी बिग चैलेंज. सो बिकॉज द developer had to make go back to the stage one after the completion. So it was very challenging. For example, once a application is in the testing stage, it was very difficult to go back and change something that was not documented. And the major disadvantages of the earlier SDLC models were कि कोई भी अगर सॉफ्टवेयर है, it was not produced, if it's produced until the during the later life cycle, there was high risk and there was uncertainty, and it was not good model for complex and object oriented projects. And it was not suitable for projects where requirements are at the moderate risk of changing. So risk and uncertainty was high with this process model, and it was difficult to measure the progress within the stages. So that's about the earlier models. Then came in the agile model. So what changed with the agile model was that it was a methodology. This sorry. So this agile model, what was special about it? So it was a methodology which focused on collaborative decision making and development over the short cycles or sprints. So you must have heard the term Scrum, staging, and all these the companies these days currently who are using this agile methodology use these terms a lot. Why? Because they adopt this software development life cycle model. They do the work in sprints, जो पूरी एक प्रोजेक्ट होता है सॉफ्टवेयर का, उसको वो छोटे छोटे पार्ट्स में डिवाइड कर लेते हैं. एंड फर्स्ट ऑफ ऑल दे डिप्लॉय अ फीचर. फॉर एग्जाम्पल देर इज अ बिल्डिंग, इफ somebody wants to design, सो वो एक उसका एक फ्लोर बना देंगे एंड देन दे प्रेजेंट इट टू द कस्टमर कि आप देख लो ये इसमें ये आप हमने क्रिएट कर दिया है, डू यू वांट एनी चेंज, दे आस्क द कस्टमर. एंड द क्लाइंट सेज कि नहीं इसके अंदर ये चीज ऐसे कर दो, वो चीज वैसे कर दो, चेंज ए टू बी एंड बी टू सी. सो देन इन द नेक्स्ट स्प्रिंट what they do is they make changes according to the customer, so that they don't have to start over and again from the zero. So that is the main advantage. So whole software development cycle is quick, it's very rapid, and the cyclic development is in the form of iterations instead all in one shot. So your teams work in multiple cycles which last between 2 to 4 weeks. तो आई होप अभी तक जो मैं बता रहा हूँ वो समझ आ रहा है सबको. लेट मी नो इन द कमेंट सेक्शन दैट इफ देयर इज एनी डाउट्स और समथिंग. Srinivas is asking any sessions for AZ104. Yes, brother. AZ104 भी करेंगे, but you can check out Microsoft Learn. There are free resources available for AZ104. You can go check out the documentation. It's free. All right. So if there are not any doubts, I'll move to the next part. All right. सो एजाइल मॉडल के बारे में अगर मैं डीपली डिस्कस करूं, इफ आई टॉक अबाउट दैट, सो व्हाट हैपेंड वाज दैट विद एजाइल डेवलपर्स, डिजाइनर्स एंड बिजनेस पीपल, they worked simultaneously. That means the real life cycle of agile development looked more like project planning, product roadmap creation, sprint planning, daily meetings. So if you see in organizations a lot, especially in startups these days, these sprint calls and scrum meetings, they are happening. So all this is part of the agile culture, and this is the adaptive approach which is it's going in at a very good stage. So of course you'll see lot more companies coming up with such methodology. So, but still, even if the agile model came into place, that was just for software development. So, nothing special was done with respect to uh, what we call is nothing special was done with respect to this IT administrators or anyone from the operations team. So there was a lot of conflict happening between the developer and the IT administrator. Still, it was happening. Why? Because the operations team. So one reason was that the operations team had difficulty to deploy and run the application due to unavailability of dependencies of application. अगर आप application create कर रहे हो, उसके अंदर डिपेंडेंसीज होती हैं, और टेस्टर बोलता है फॉर एग्जांपल कि मेरी मशीन पे ये मैंने टेस्ट करके देखा इसको अपने सिस्टम पे, ये ऐप चल रही है. बट देन व्हेन इट स्विच टू द आईटी एडमिनिस्ट्रेटर, इट मतलब नेक्स्ट स्टेज को अगर वो जारी है, वो कह रहा है कि इसको सर्वर पे डिप्लॉय कर दो, अब ये मशीन, अभी ये जो एप्लीकेशन है बिल्कुल टेस्ट हो चुकी है हमारी तरफ से. बट देन आईटी एडमिनिस्ट्रेटर सेज नो, बट इट्स नॉट रनिंग ऑन माय मशीन. So then conflict arises. It's sent back to the developer team, and then they build and test it again. But they say, no, it's already running, but it's your system which has the fault. But it's not the IT administrator's system, it's the dependency. तो ये चीज कौन बताएगा? ये चीज उसको नहीं पता, आईटी एडमिनिस्ट्रेटर को. ये डेवलपर को पता है. और ये जो कॉन्फ्लिक्ट है इन सब चीजों की वजह से ही होता है. एंड इफ एप्लीकेशन डिपेंडेंसी मुझे नहीं पता है, तो फिर मैं आई बी जस्ट सो व्हाट एट द एंड ऑफ द डे व्हाट विल हैपन इज कि जो डिलीवरी टाइम है प्रोजेक्ट का, फॉर एग्जांपल इफ द क्लाइंट आस्क द प्रोजेक्ट कि मुझे या 8 दिन के अंदर चाहिए, मुझे फॉर एग्जाम्पल 8 दिन, चलो मैम बहुत कम बोल दिया. If it comes to, like, if it's a 5 month project and I couldn't deliver on time because of these developer versus IT operations team issues, then the project was delayed to 8 months. तो ये कंपनी का भी नुकसान है इससे, टीम का भी नुकसान है. So the productivity goes down because of this. So let's jump in brief to the discussion की होता क्या है ऐसे. So first of all, the developer builds, he writes the code, he puts it in the build stage, then it goes to the testing stage, then the quality assurance team checks for any bugs or anything, and then once this test is passed, this team goes to IT administrator operations team saying कि इसको डिप्लॉय कर दो आप सर्वर के ऊपर जहाँ पे कस्टमर को चाहिए. So if it's a normal web application, either they go to the normal, cloud hosting or something, Azure or data center, wherever they require. जनरली सब लोग आज क्लाउड पे ही होस्ट करते हैं बिकॉज इट्स मच मोर फिजिबल, पे एज यू गो मॉडल. उसके बाद जब वो डिप्लॉय के करने के लिए जाती है, एंड देन इट्स देन इट्स मॉनिटर्ड एंड इट्स सपोर्ट इज प्रोवाइडेड टू द कस्टमर कि अगर डिप्लॉयमेंट के बाद सर्वर के ऊपर कोई इश्यू आता है तो उसको कैसे चेक करना है. ऑल दिस टेकन केयर बाय द आईटी ऑपरेशंस टीम और सपोर्ट टीम. बट बिकॉज ऑफ इश्यूज लाइक दिस, जो कॉन्फ्लिक्ट्स होते हैं, वो उसको रिजॉल्व नहीं हो पा रहे थे. दिस इज बिफोर द डेवऑप्स. So same issue happened with the QA team. The software was developed and tested for months, but leading it up to the release, the QA was scrambling to test everything and then send back the defects, while the devs were scrambling to fix bugs and then send back to the QA faster than they could send them. So the night before the release, QA and operation team would recommend the release date should be pushed back because the software is not production ready. So all these things contributed a lot to rising conflicts. So what happened? So in 2009, the first conference was held by the name of DevOps Days, which was held in Ghent, Belgium. And this conference was founded by Belgian consultant जो इनके करता धरता है project manager and agile practitioner Patrick Debois. Yes, that's the name of the guy. He delivered this conference, and there was one another YouTube video which went viral from the ex Flickr and Yahoo guys who discussed the same thing that year about developer and operations teams working together. Why? Because there was wall of conflict between the dev and operations. तो फॉर एग्जाम्पल, अगर ये डेवलपर है, डेवलपर ने ऑपरेशंस टीम से काम करवाना है, तो ये वॉल ऑफ कॉन्फ्लिक्ट, ये उनको भेजता था कोड, ये कहता था कोड चल नहीं रहा मेरी मैंने सर्वर पे डिप्लॉय करके देखा है, ये इसको फिर वापस भेजेगा, वो कहेगा नहीं मैंने मेरी मशीन पे चल रहा है. एंड देन द सेम थिंग केप्ट ऑन हैपनिंग. एंड देन ऑन द अदर एंड ऑफ द साइड जो प्रोजेक्ट मैनेजर है वो कह रहा था कि तुम काम क्यों नहीं कर रहे. So all these conflicts had to be resolved and switched to today. Now these teams are working together. Why? Because it's all centralized, all because of DevOps. So how this happened, we will discuss it in the later slides. So this was the history of DevOps basically, that why this used to happen. And basically, so let's also discuss key what problems was DevOps trying to solve. So all the processes DevOps was manual. So all these processes from the developer and operation side was manual. So DevOps aimed to maximize the speed and efficiency of the operational process. So as DevOps was meant to be fixing the inefficiencies, uh, like it was raised by the like waterfall method or any other SDLC. Its goals were to lower the failure rate of new release, and also faster mean time to recovery and shorter lead time between the fixes. And the you see today, you can take example of Netflix. So Netflix, what happens that it has the ability to make hundreds of deployments per day. So if you can imagine a world where you can deploy once a month or once or even few months, that was the reality of developers back then. So but with the DevOps, the development operation teams are no longer different. So they team are merged into single team, and these developers can and operations guys, they can work together along the full application life cycle from dev and test to deployment to operations. So all these things are managed automatically now. So now let's discuss the other prerequisites. One is the, let's understand build automation continuous integration in very simple terms. In very simple terms, okay. So build automation is what? So it's basically, it allows users to automate testing, monitor the code delivery. So what it means it that if a coder has uh, application, he wants he has written the code already, but in order to uh, build the code, what are the methodologies? Everything used to be manual, but this build automation, as the name suggests, it's take everything in an automatic manner. What are the advantages of it? So it helps you to create and build the software without human intervention and compile files into usable form. And Jenkins is a good example of it. You might have heard this term, tool. So what happens is that when you create, when a coder has he has written all the code, but it needs to be compiled, minified, linked, and transformed. So currently, what the college students do is that they work on some mini projects. I mean, I'm just taking an example. Uh, so sometimes when in the starting stage, when a coder is doing, it takes like very less time because he's working on very simple C++ Java programs. But when you work in the industry, you'll see that you are working on very large software. So of course, compiling, minifying, linking, and transforming that or building basically the whole thing of the code and making into an executable form is a very challenging task at times because you are working with very large softwares. So with build automation, all these tasks were done manually, but now because of build automation, all these tasks are automated. So the process is in a speedy manner. So all the tools for build automation are dependent on different programming languages. So Java has Ant, Maven, Gradle. JavaScript has npm, Grunt, Gulp, and there is a Packer tool which is used for build machine images or containers. So all these things are important. Next is continuous integration. वो क्या होता है? It's an instant practice of merging the code changes done by the developers. So good example is Azure Pipelines. So what it means it that it's a so for example, what happens is that in software development practice, where developers regularly merge the code changes into a central repository, after which the automated builds and tests are run. So continuous integration refers to building or integrating stage of the source release process and entails both automatic component and cultural component. So the key goal of continuous is integration is to find and address the bugs quicker, improve the software quality, and reduce time to validate the software update. So why it's needed? Why continuous integration? So in the past, all the developers they wanted to uh, work in isolation for an extended period of time and then merge their changes to the master branch. Only their work was completed. This made merging code changes difficult and time consuming. So there were a lot of bugs and there was a lot of time taken to correct it. So that's why continuous integration was introduced. So अगर कोई कोडर है, 5-6 कोडर एक प्रोजेक्ट पे काम कर रहे हैं, वो अलग से अपना किसी ने पहले उसको रिजॉल्व कर दिया, ही कैन फर्स्ट ऑफ ऑल do not there's no need to work on the same software. You can create your own branch. You want to work in a new feature. If the feature is good, they'll push back into the master branch. नहीं तो फिर वो feature को use नहीं करेंगे. And similarly, uh, so basically how it works, so in continuous integration the developers frequently commit to the shared repository using a version control system like Git. So prior to each commit, so the developers may choose to run local test units. So first of all, they'll They'll test that thing, new feature in the same so for example, there is a shopping cart feature which you want to add in your e-commerce application. And then if developer A and developer B are currently working on a new feature, so developer A creates his own new branch. He does not work in the main branch. He creates his own code, he runs it in the local system. If the code runs well in the local system, then he gets extra verifier uh, layer before integrating into the main branch. So automatically build and testing these things, it's become easier. Similarly, continuous delivery, so it's a practice where code changes are automatically prepared for a release to production. So it's a very modern phenomena, and the continuous delivery expands your integration by deploying all your code changes to a testing environment or a production environment after the build stage. So developers do not have any, they do not need to wait for deploying their code. It's continuously in a new feature they can test and then deploy. And there always a development ready artifact available or blueprint available, which is passed through a test. So you can use either Azure Pipelines or Atlassian CI/CD. So these are important tools which you can make note of. So basically these are the generally steps taken. This is not the exact architecture, but of course it's just an overview how things happen in the DevOps scenario. So version control, uh, where all the source code is managed, uh, and then it goes to the we do continuous integration, then delivery, and then deployment. And after that we go on and manage those in the whole process. All right, let's see if we have any doubts or all right. So now coming to the main part, that initially we saw that how there was conflict between the developer and the operations team. But now we know that after DevOps was introduced into the teams, how these processes, how the teams interacted together and now part of the same goal. uh, let's discuss that. So initially, now we see that this is left on the left hand side is the developer part, and the right side is for the IT operations part. And the so in the left side we see that the code is first of all planned, and then the code is built and tested, and there is a planning done, the code is built and then it's tested. Next is on the right side is the deployment, operation and monitoring. So first of all, the continuous development is done. Here we can use in this phases, in these two phases we can use certain tools which will come across in the later slides. um, and apart from that, there is a continuous testing. uh, we, that feature is done, and after that there is continuous deployment. So specific tools are there for this whole scenarios. And there, meanwhile all these is taken place, there is integration between the whole teams. So nobody, for example, if there are the test run uh, for a specific code, but there is some error, and then the whole team is given an alert that this application was tested, but this there is a specific error. So everybody is aware of the situation. Now the specific person can be assigned a task, and he can fix the bug, and then we can continue the whole process. So for example, in the coming time, there is an issue in the deployment, and then the whole team is notified that there has been a specific issue with respect to this deployment of an application. Now that concerned person can directly jump onto the call, and then he can discuss with the person from the deployment team. So developers and operations team are working together. Also, they are resolving the issues on time, and everybody is aware about the situation. That's the beauty of DevOps. All right. So let's discuss in brief about the version control. So what version control is, and how do we how it's important in the DevOps scenario. So basically, version control system is a software which helps to manage change to the source code over time. So as developer environments have accelerated, the version control systems help software teams work faster and smarter. So they are especially used in DevOps since they help to reduce the development time and increase the successful deployments. So version control software keeps track of every modification to the code in a special kind of database. So if a mistake is made, the developers can turn back to the clock, and then they compare the earlier versions and then help them fixing the mistake while minimizing the disruption of all team members. That's how it is. So basically there are so if for example there is a um, so initially there was just one version available called centralized version control. So repository is basically central storage. It's central storage, nothing else. Where it's a server where in the earlier days of central version control, there used to be, for example, one two three developers. So if they had code uploaded over here. So if for example there is a person, developer 3, comes to know that this specific software has a feature to be added, so he'll uh, pull the code to his local machine, he'll work on it, he'll add the feature, and he'll commit back to the central repository. Similarly, then the developer 1 comes to know that there is a bug, but there is a bug in this and this can be improved. He again pulls back that copy of that software and then again works on it, and then he commits back. But s- uh, error comes when developer 2 is unaware about the situation, but because he initially worked on the project software 1, but after all the changes were done by developer 3 and 1, he doesn't know that what how the code is written, and there are no comments. So of course this guy is in they has some issue. He has to first of all get in touch with this guy and this guy, and then after few discussions he can easily he can start working on the project. So also there were a lot of issues. For example, n number of developers are directly uh, making lot of changes into the software. So of course it will be runny, patchy, and there were a lot of had been issues with respect to it. So it was very difficult to manage, and sometimes the server won't even respond. So Linus Torvalds, the founder of Linux, had to introduce. He was quite pissed off with this central version system, so he introduced a distributed version control. It was very different from. It was very different with respect to uh, the independence was a lot more. Why? Because there was a local repository embedded. So anybody who wants to do their own changes, they can first of all get it in the local repository, and then he can push and pull from the central repository. Each person had their own version of the code on which they can work. They did not need to just get there, or first of all get directly from the central place. And this was whole based on Linux, so it's open source distributed version control system called Git, which we'll be discussing. So let's jump on to the Okay. So this is the main architecture of the Git. So basically it's a overall scenario. So if Git, it's a open source controls, a distributed version control system which you can install on Windows and Linux machines and even Mac. So what you can do is, it's your working directory, it's your code, it's written over there, and you can add that code into the staging area. And now after staging area is basically this your local repository, and then staging area, and then goes to the commit to the local repository. So this is in your PC, this is not so you create the code and then you add it in the staging area and then commit to the local repository. And it's and then if you are 100% sure, then you can push the code to GitHub. GitHub is what? It's a central repository or cloud based storage where all the developers can uh, get the code, and then they can pull it onto their machine in the local repository, make changes, push back again. So that's how it works. Similarly, there's a developer too. He has his own working directory. He pulls the code from GitHub to his local machine. He works there, he adds his features, he commits, and then pushes back to GitHub. So that's how distributed version control system works. And GitHub is nothing but a central repository, cloud based storage. It's one of the top platforms used by uh, all the developers around the globe. So now let's discuss in brief about the how DevOps is in a very realistic manner, kind of, let's say. Okay, so how this whole cycle starts in general. So there are customers or clients, we have, and they run a requirement workshop with the project manager or solution architect. Suppose there's a company named ABC. They work on certain DevOps projects. They work on uh, web development, app development, and uh, so what they do is, the customer, they wanted to build some application. They have a discussion with the project manager, solution architect. They run a requirement workshop. Then they discuss all these. When all the requirements are taken, कि मुझे ये application चाहिए, ये feature चाहिए, all these requirements are taken regarding the application. They jump on to uh, taking help of software for project management and issue tracking like Azure Boards, Jira, Backlog. So what they do is that all these this project management and issue tracking softwares are used, or services are used, to gather input and make sure that all the requirements of customers are fulfilled. So what they do is they assign specific tasks to a team of developers. That, for example, if they are using Agile Model, they'll run short sprint cycles. For example, they'll say uh, person A can work on a feature of the UI, and person B, they can work on the payment gateway. Person 3, or the developer 3, they can work on the main uh, application page, so on and so forth. So all these tasks are assigned on the Azure boards. So once all the tasks are assigned, and every person has been you know got the specific role, or what feature they have to develop, it's all very easy and convenient to manage. And amongst these developers, there'll be along also a DevOps engineer who will be working along with them to manage the whole thing. So now after the developers are signed, we'll get to know there is a source code management. So all these developers, they work on this. So lot of things like we already discussed. Source code management is they can use Azure repos, GitHub, GitLab, all these software. So what happens is that all these version control system, as we discussed, they are used practically here. So they have their own they some of the developers work on front end, some work on back end, and also there is a infrastructure as a code. So what happens is that once they create the specific, all the developers have worked on the code, they will need some place to deploy, they will need infrastructure. So what they will do is they can use specific uh, uh, tools or services like Terraform. So what it does is, you can Terraform is a type of is another option which you can use that to create the infrastructure. You can write the code, and you can enable the infrastructure for hosting your application. So what it does is that, for example, if you have earlier, what used to happen is that in the earlier times, there used to be, for hosting your application, you needed on premise, you needed to talk to a vendor or OEM. They would procure servers to you, database or application servers. But now, what you can do is directly provision Azure, AWS, or data center, and from data center directly you can get a portal and then host your application there. So either your application could be hosted on a virtual machine, or you can use containers, Kubernetes, and there will be some other elements also therein. So if you're using SQL database along with that, so this is your hosting environment. So what infrastructure as a code does is, like, you can just write specific code uh, on the platform, and then your infrastructure will be provisioned therein. You do not need to done it manually. And all this is done through the CD pipeline. So what happens is that CI is the continuous integration, where what happens is that once the code is written in the front and back end code is written, it will be built through the Jenkins or other tools. Then code quality will be tested, code testing will be done, packaging of code will be done using the package manager called the Azure Artifacts, which you can use. It's also part of the suite. So, and then in the CD is the continuous delivery, where the dev test environment, UAT, production environment is given for the. So you do not need to worry about the environment, because environment is readily available uh, for your application to be tested. So that's how its CD pipeline is working along with this whole cycle. So that's how is the basics, how you can use the DevOps, Azure DevOps services. So along now, let's jump on to the main slide. All right. So let's discuss in brief about the GitHub. So GitHub basically it's a collaboration platform. So from software to legal documents, you can count on GitHub to help you do your best work with the collaboration of the security tools your team needs. With GitHub, you can keep your projects completely private, invite the world to collaborate, and streamline every step of your project. So GitHub is also a very powerful version control tool. So GitHub uses Git, the most popular open source version control software, to track every contribution and contributor to your project, so you know exactly where every line of code came from. And GitHub helps people to do much more. So GitHub is used to build some of the most advanced technologies in the world. So whether you're visualizing the data or building a new game, so there's a whole community and set of tools on the GitHub that can get you to the next step. So uh, this is all about that. This is much about that. And now, last but not the least, we are going to discuss in detail about the Azure DevOps. So as we discussed in detail, what all things are required in the Azure, what are details are required for the main for using the DevOps. So basically what, let's discuss one by one. So Azure DevOps, So it's Azure boards. So Azure boards provides the software development teams with the interactive and customizable tools that they need to manage their software projects. So it provides a rich set of capabilities, including the native support for the Agile, Scrum, Kanban process, and calendar views, configurable dashboards. So all you can basically use Azure boards to easily track your work, and if there are any issues with respect to the uh, code, or there are code defects associated with your project. And Kanban mode is shown in the image. uh, you can see, you can look up Kanban board options, uh, and you can see that one of the tools which allows you to add, update, and filter your user stories, bugs, features, epics, all these things you can manage from there. So in Azure boards, you can track various types of work using different work items, such as I discussed, like features and epics, or you can customize these types or create your own. And each work item form provides a standard set of system fields and controls, including discussion for adding and tracking comments, history, links, and attachments, and deployment, development, and related work, which controls support tracking when code is released or changed, and relationship between the work items. Also, you can use interactive backlogs, board list, and calendar views. So you can open work items for personalized list. And next, let's discuss the Azure pipelines. So this is used for the continuous integration and continuous deployment. So what it does is that it helps you to uh, integrate uh, your extended integrate your code, merge your code changes into a central repository, after which the automated builds and tests are run. And continuous delivery is used of to where you can automatically prepare for a release to production, and this helps you to deploy all the code changes to a testing environment. So you can connect Azure pipelines to your GitHub or any other Git provider and deploy continuously. And similarly, Azure Repos is a version control system similar to Git, and it's a collaborative to provide better code and pull requests. So basically, Azure Repos you can use as a feature wherein you want to do source control management. You want to similar to Git, it's that stuff. And next is the Azure Test Plans. So if you want to do testing of your application, this is the service to go for. And similarly, Azure Artifacts is a package management solution. So what happens is, if you are currently not having, as we discussed before about the package management issues, so some uh, IT, what happens is that there is a specific package which is to be distributed to the whole team, but we do not have any options. So what happens is that we can use Azure Artifacts. We can list down n number of packages required, then it's all done. Similarly, extensions marketplace, where you have up to 1000 apps and services which is built up by the community. So that's about it. Thank you so much. Let me know if you have any questions.
Hi, we would be happy to take questions. And if there are no questions, then we'll call it a day then.
Okay,
Yeah. So
sure,
I don't see any questions coming in the chat, but I'll keep you posted just in case I get some queries. And
sure.
thank you very much, Agam, for taking up time on a Sunday evening. And we look forward to more sessions with you. Thank you very, very much. Have a great evening or whatever is left now. Thank you.
Sure, Namika. Likewise. Thank you so much for
Thanks.
having me.
Thanks. Oh, there's a question for you, Agam.
Sona Hassan. Okay. All right. So basically, TFS is the Teams Foundation server, the which is used on premises, or let's say we call it the data center version. So Teams Foundation is originally a part of Azure DevOps, but now its naming convention has changed to Azure DevOps. What used to happen is that initially Microsoft used TFS when they launched DevOps on premises, but now because they want to adopt in the cloud, and it's much more feasible to use TFS in the cloud itself, so now the naming convention has changed. That's about it.
Any other question? No. All right then. Thank you very much.
All right.
Thanks.